and welcome to My Career in Data, a podcast where we discuss with industry leaders and experts how they have built their careers. I'm your host, Shannon Kemp, and today we're talking to Mike Schumacher.
More and more companies are considering investing in data literacy education, but still have questions about its value, purpose, and how to get the ball rolling. Introducing the newest monthly webinar series from DATAVERSITY, Elevating Enterprise Data Literacy, where we discuss the landscape of data literacy and answer your burning questions. Learn more about this new series and register for free at dataversity.net.
Hello and welcome. My name is Shannon Kemp, and I'm the Chief Digital Officer at DATAVERSITY, and this is My Career in Data, a DATAVERSITY Talks podcast dedicated to learning from those who have careers in data management, to understand how they got there, and to talk with people who help make those careers a little bit easier. To keep up to date in the latest in data management education, go to dataversity.net/subscribe. Today, we are joined by Mike Schumacher, the founder of Lakeside Software. And normally, this is where a podcast host would read a short bio of the guest. But in this podcast, your bio is what we're here to talk about. Mike, hello and welcome.
Hi, thanks for having me. It's great to have a chance to talk to you today.
Likewise. Okay, so tell me, you're the founder of Lakeside Software. So tell me a little bit of what's Lakeside Software? What do you do?
So Lakeside Software builds cloud software that helps organizations improve the digital experience of their employees. And what we mean by that is we build tools that help companies manage PCs, Macs, Android, iOS, Chromebooks, whatever it is those people are using kind of in their day-to-day work. We help to kind of reduce some of their frustrations by making them better. And making them better means solving problems, hopefully avoiding problems before they happen. It involves getting the right hardware for the job, getting the right software for the job, solving all those things that result in a frustrating experience for people. But it's actually like a double win, because besides making people happier by delivering a better experience for them, we also try to help on the company side by delivering that experience at the lowest possible cost. So, most companies are perfectly willing to buy tools and buy what it takes to make a great experience for their employees, but they don't want to overpay, and they certainly don't want to have to hire a whole bunch of help desk staff if they can avoid those problems in the first place. And so there's a lot of wins that happen on the kind of the employer side of things as well. But overall, the software we build collects data, and then it analyzes that data and helps people to improve that daily employee experience.
Oh, I love that. Very, very interesting. So as the founder, what do you do in your daily job?
Well, it certainly has changed over the years. I've been at Lakeside for 27 years. And in the beginning, I built software. I am a software engineer by trade. My formal university training is in computer science and computer engineering. And when the company started, there was nothing. It was just me, and I was Lakeside in my den, actually. So my first job with the company was to design a product and then build a product. And of course, that product 27 years ago wasn't kind of the same level of sophistication that we have today, but it was the initial offering of the company. And then, over time, as the company had some successes, of course, we hired some people. We hired some more engineers, some engineers that are better than me by a lot. But then my job became more of managing engineers than it was sort of doing the work myself, which took a little doing to understand and get used to and hopefully get better at. I also took on all of the business responsibility. So, it was a startup, and I was the CEO and the CTO. And so I wore a lot of hats. So I helped in a little bit in sales and a little bit of marketing, but my biggest kind of value add to the company was in kind of the vision for what should the product do, how should it work at a kind of a high scale. Eventually, I took on an investment from Insight Partners. They became my partner to kind of help drive the company to the next level. When an organization reaches a certain size, there is an expertise to actually managing and operating and scaling and growing that company. And Insight really brought that. And so with Insight, we brought on a management team that has a lot of experience in growing and scaling companies. It's not their first time around. And so my job changed again. And today I'm a board member. So we certainly help out the management staff the best we can, provide a little bit of advice from time to time when they ask for it. And I also still get to help out in kind of the longer term strategy, the longer term vision for the company. So I do, rather than thinking about things that are in the short term product roadmap and features and things like that, I spend a lot of time thinking further ahead, multiple years ahead to where does the company need to be? What do we need to invest in order to get there? And maybe not so much on the detailed, how do we implement that from an engineering standpoint, but more from a what does it need to do in order to kind of lead in our digital experience management space. So that role, kind of a long answer, but that, what do I do for the company has definitely changed. But today, probably the biggest thing is kind of that long-term planning work.
Oh, it makes a lot of sense, and I can certainly relate, being a small company ourselves. So, and congratulations on 27 years. That's amazing.
Thanks. I should add too
Yeah.
that it's a lot more fun for me. I'm an engineer, and I love working with software and building things. And so, as the company kind of grew, that CEO hat took up an awful lot of hours, incredible number of hours. And so kind of the new role is certainly more daily, exciting and fun for me because I get to spend more time doing what I really love.
That's awesome. So tell me then, Mike, how do you work with data in your current role?
Great. Data is actually really key. In fact, as we look at the competitive space, which I won't get a lot into in our market today, probably beyond the scope of what we want to talk about, but our biggest advantage over our competitors is that we have this data advantage. We have built an architecture. It's a very unique architecture that uses a combination of edge and cloud together. And by edge, I mean in our product, we're managing tens or sometimes hundreds of thousands of devices just for a single customer and millions in the aggregate. There's a lot of horsepower there and a lot of horsepower that's unused. And so in our product, at those actual managed Macs and PCs and phones and whatever it is, we run a data collection agent that gathers data and it stores it locally. It doesn't send everything over to a central location immediately. It also does analytics and takes actions and runs remediations all kind of on its own on that device. And we call that kind of the edge. And then there's a little bit of data that we do centralize, and some of it we set up by factory, some of it, we decide by configuration. And then we have ways to kind of gather that data instantly if we want from massive estates into this cloud. But this combination has been very valuable to us. It's complex to program. And to manage and maintain, from a software perspective, but from a customer standpoint, in the UIs, it sort of looks like it's all in one place and it works pretty seamlessly. But it gives us this huge advantage that the cost of collecting and managing data is almost zero. So we don't need a lot of network bandwidth. We need a tiny amount of network bandwidth. We don't need a lot of central horsepower processing, power. We really do that work mostly out at the edge, and the cloud serves as kind of the command and control and UI location, for all of that. But the net effect is we don't have, like our competitors, we don't have any trade-off between what we want to collect and scale and cost. And so in our case, we'll collect a couple of maybe 3 orders of magnitude more data than what our competitors collect. And that's both or all three in terms of breadth, how many different kinds of objects like users and applications and headsets and keyboards and mice and lots and lots of breadth, a lot of depth. So when we talk about any one of those one objects, the number of things that we collect about an application or about a PC or about a motherboard is also very deep. So we have both the breadth and the depth. And then the third dimension that a lot of people forget about is kind of your history. It kind of makes up a cube, you could think. So it's how long do I keep that data around? And in our business, that's incredibly valuable because it gives you the ability to analyze trends over time and to look and see, how were things running or how were they set up back when things were better? And now when we have a problem, we can kind of look and sort of figure out what that cause is. So like a classic example is we might detect a problem with a PC where you have a poor network connection. And we might say, wow, that network connection is, you're connected to your switch at 10 megabits. Well, why, is that the problem? Well, it depends, because there are places in the world where that's a pretty good connection. There's nothing wrong with that. But there are other places where, like on my home network, even I'm running gigabits. So it would be way bad. So how do you know without having to have someone configure it or tell you? The answer is you just look at the history. Like if I was connected at a gig all of last week and I'm connected at 10 meg today, something's wrong, right? So that history, that's a very simple example, but there's much more complicated real world examples where having both the breadth and the depth and that history, the size of that cube, really drives a lot of our competitive advantage. So we take that data and we build a lot of use cases on top of this that depend on that content. So when you say, well, how do you work with that data? Well, we do a lot of things, right? We first collect it and clean it and homogenize it and save it, but then we analyze it and do things with it. So what would we do? Well, in our world, we might use it in a very simple case for like reactive help desk. You call the help desk because something's wrong. And rather than them start out by saying, well, do you have Windows or Mac? What version do you have? What kind of a PC do you have? How long have you had it? How long was it installed? When did you last reboot? How many applications are open? Rather than ask you all these questions, the software just uses the data content and it puts it in front of the technician instantly. So the technician just looks, and not only do they have those answers, but we can color code it and tell you all these things are okay, but look, you're low on disk space on that machine, or your latency to your default gateway is high. So we can just take so much work out of that reactive case, even to the level of there's more than 1,000 specific problems that happen that we can directly detect and tell you this is the problem on this device. It started here, and here are the steps that you take to fix that. In some cases, we provide a script, run the script, and it'll fix it. Taking the reactive case, though, a step further, we do like proactive things. It's very expensive to help people one at a time. I don't like to call the help desk for anything. You probably don't either. I have better things to do with my time. So a lot of problems really go unreported. You'd be surprised with what people live with on their PC. I tell people, like, if your car behaved like that, they would tell you, well, just pull over to the side of the road and turn it off and turn it on and see if it's better now. You would never accept that. But people on desktop computers, they do accept that. So we have like this proactive approach that maybe doesn't care just about Shannon so much, but it cares about all the Shannons. So I look across the whole organization and say, wow, look, there are like 3,000 people having the same problem with this same application. Instead of fixing them one at a time, if we were to solve that problem and deploy the fixes, all these people would be happy at the same time, and it would cost way less than fixing them one at a time. So this proactive use case is really motivating for large enterprises. And then there are other things that we do, like, you're about to upgrade your laptop and you want to know what kind of machine should I buy next. We can tell you how much horsepower you need, how much CPU, how much memory you need, whether you need a mobile or a fixed device, all kinds of things that go into kind of sizing that. And similarly, we can tell you what software you need, and probably more importantly, what software you don't need, because people have systems that are just cluttered with software that they don't need. and it's just this bad news. It's more work for support. There's more things to go wrong. That right sizing equation kind of comes in again. So those are kind of some of the things we're doing today. We can talk later if you want about some of the newest use cases that are leveraging AI and ML, doing some pretty interesting stuff with the data. But if you're interested, we can talk about that later.
Well, it sounds like you're doing a lot with data, which is really exciting. That's some really cool use cases of how data can help a company and how you're leveraging it into your own software. So, but let's back it up, Mike, a little bit, and let's talk about how you got to where you are, and this passion that you have for this company and what you do. So even before you got into college and got your degree in computer science there, what did you want to be when you grew up, when you were just say 6 years old? What was the dream? What was the original dream?
I don't know about 6 exactly, but I do know that I always loved math. Math was just my thing. I liked it. I was decent at it. And it was just always something that I really thought, this is something I'm gonna do as a career. And in fact, when I applied to college, I applied to be a math major. I was going to get some combination of an engineering and math degrees, and got into University of Michigan, and I lasted for one term in math. I started I think in Calc 2. I tested out of Calc 1, and I started in Calc 2, and I fairly quickly realized that this was not going to be how I wanted to spend my life. Math was okay, and I ended up taking just a ton of math in college still, which was not directly useful because I don't do a lot of multidimensional calculus in my day-to-day work. I don't do any. But some of the concepts and the underlying thinking and so forth that are driven by math discipline are actually pretty useful in all kinds of engineering. But I in that first term in college, I also took my first course in computer science, and I absolutely loved it. I mean, I'm not going to date myself too much by telling you about the technology that we were using because it was not very exciting, but I just really loved it. And I took a second term, and I knew at that point that it was going to be computer engineering for me. And I actually studied kind of a combination of hardware and software. I took a little bit of electrical and computer engineering classes too, but it was really software that I always kind of loved. And so I guess when I was young, I wanted to be a math student, and as I got older, I decided it was going to be something in computer science or computer engineering.
Oh, very, very interesting. So, okay, so you've got your degree. So what happens then? What's the first job out of college?
Out of college, first, when I finished my bachelor's degree, there were still some things. There were some advanced courses that I was really interested in taking, and I just didn't have time to fit them in. So I decided to stay for a master's program at Michigan. And I got to take all those classes, and it was very enjoyable. It was hard work, but it was very enjoyable. In fact, for a while, I toyed with maybe I would go get a PhD, but the first job that I had involved a lot of travel, and that kind of killed that off. So I was looking for what position I wanted to take. I had a number of different opportunities, but there was one to join the Industrial and Technology Institute, ITI, which is kind of a new thing out of Ann Arbor. It was a nonprofit R&D institute, and I was connected to them because one of the professors that I had worked with in my graduate program was consulting and working for them. And so I kind of had this connection to see what they were doing, and they were doing a lot of really interesting stuff, really cutting edge stuff. And so I decided to join them. One of my first assignments, one of the things that I got into relatively early was a lot of ANSI and ISO work related to computer networking, and specifically the 7-layer models and some of the early standards work for general use, and then some specific stuff in the manufacturing world related PLCs and robots and CNCs and how to kind of standardize networking communication among these kinds of devices. But that job for especially for the ISO stuff required a fair bit of travel for long periods, like, not for a day. They were like, a week at a time or more, 2 weeks. And so I decided that PhD program was not going to happen because I was gone all the time. But I loved it. I got to see a lot of the world, and I learned a lot from working with some really smart people, not just about technology, but how to negotiate, how to kind of influence people, how to work with people and also influence others and be influenced sometimes by what other people had in mind. I met a lot of people with a lot of very diverse views, and it was a great job. It really was great for me. I learned a ton. But after a few years of doing that, the travel was just killing me. The same thing that I really loved in the beginning kind of became, yeah, I've been there, I've done that. I just want to be at home. And so I ended up joining a company to build, to really build products. And the first thing I worked on was in those days, people were connecting IBM mainframes to early like Novell local area networks, and they were using emulation for the 3270 terminals that you connect to a mainframe, to an IBM mainframe. And I built kind of the same sort of thing, but for Honeywell Bull mainframes. That built a bisynchronous gateway. Get too much details, but low level communications that ended up turning into something that you could use to share modems. And you might say, well, why would somebody share a modem? Well, the reason is the modem required a phone line. Phone line had a monthly charge, and it was compelling to do that. And so I ended up building a modem sharing device, and then that company got acquired by Telebit out of Sunnyvale, California. And so I went with the deal and moved out to Silicon Valley, and had a new job. And my new job there kind of switched from, I still have my old products, but also became heavily involved in managing the team that built their dial-up routers. So in the early days, it was kind of an extension, right? Using those phone lines, but connecting networks together through a dial-up system. And, we built high-speed modems that were 56K, right? And so you learned a lot about conserving bandwidth in those days, that's for sure. But it was a good experience, and I learned, I had the ISO and ANSI background, so I knew a fair bit about networking protocols and so forth, and that turned out to be a very useful skill in that dial-up routing world. But after a couple of years in California, I felt like I wanted to move back to Michigan, friends and family and so forth. And so I moved back and took a job with a company called Cubix. Cubix was a hardware company that built single computers or a whole computer on a single board. And then they had a rack, a 4U rack that would hold 18 of them side by side. So it's kind of really early, high density sort of computing. And I built for them. I built a skunkworks for them, building whatever software they needed to support that effort. So, I built, I did some hardware testing. I built emulators for keyboards and mice, and I built all kinds of stuff, whatever they needed. But the last thing I built was some Citrix load balancing software before Citrix, existed. And they were a good company. I've been there about 4 years, but they were a hardware company and I was a software guy. So I like to say sometimes that I was kind of like an evil that they had to put up with to sell more hardware. And so I decided to set out on my own. And people were, in those days, were trying to figure out, Citrix was what I worked on. I knew a bunch of Citrix dealers. People were trying to figure out how many users fit on one multi-user system. So I built a, kind of back to data here now. I built a system to collect a lot of data about that Citrix terminal server behavior and be able to forecast from that data, how much CPU do you need, how much memory do you need, how to balance your resources, and how many people will fit. And so that was Systrack 1. Systrack is the name of the product that my company sells today, that Lakeside Software sells. A couple of years later, Citrix called and said, "Hey, we love working with you guys. You're great for helping people on board, but you're tiny." I think we were like 6 people or something like that. You're tiny. We're worldwide. So we sold them a source code license. And then over the years, Systrack changed. We decided to build that edge architecture that I was talking to you about in order to run on desktops and try to understand people behavior. Like, what apps do you use? Where do you spend your time? How do I improve that? And then along came VMware around 2008 or 9, maybe. And that was like a perfect storm because they had kind of a little bit of that multi-user flavor, and they also had a little bit of that people behavior desktop kind of problem. And that evolved eventually into digital experience management that we have today. And I kind of told you that story early on about starting as one guy, one man, and eventually ending up in a little different kind of role. So in a nutshell, there's my life, at least my work part of my life story.
With a robust catalog of courses offered on demand and industry-leading live online sessions throughout the year, the DATAVERSITY Training Center is your launchpad for career success. Browse the complete catalog at training.dataversity.net and use code DVTalks for 20% off your purchase.
I love it. Very, very, very interesting. So tell me, Mike, what's been your biggest lesson so far in your career?
I guess I'd probably pick 2. I would say as an engineer, it took me a long time to really grasp the idea that you have to solve problems that people have. It seems obvious, right? But sometimes you can build things that are really cool. And as an engineer, you look at that and say, this is like a really great thing. I especially when I was at Telebit, Silicon Valley, we built one product, without getting into the details again, that was incredibly cool. Every single person you showed this thing to would say that is really an engineering marvel. But we didn't sell very many of them. And I realized over time that, like, just because something is incredibly cool and, as an engineer, it doesn't necessarily mean that it makes a great product. And the question you have to ask yourself is, does this solve a problem that people actually have? Because if that answer isn't really true, you might have more of a hobby than you have a job, and I would say kind of very closely related to that is a second question, a follow-up question for that is, do these people know that they have that problem? Because sometimes people have a problem, they just don't know it yet. And you have to know it's okay, but you have to know that your sell cycle for that is going to be long, because first you got to educate people that they have the problem, and then you can sell them something to try to solve the problem. So I would say as an engineer, that is probably a huge macro lesson that I learned. And I've built a lot of stuff over time that doesn't check that box, that it's really cool, but it doesn't really solve a problem that people have. And I hope I've gotten better at that over the years. I would say, though, if you ask me the same question from a business perspective, from an entrepreneurial perspective, then I would have a different answer. And my answer would be, the lesson is it's all about the people. It's 100%, well, 99% about hiring and motivating and working with the right people. And at Lakeside, probably the thing that I did better than anything else was hiring just an incredibly talented group of people, far more talented than me at engineering and every other discipline, and getting them to work as a team together. And I really think that, like, if there's so many great people, and I've told people before that if I took my same team and I wanted to build an ice cream store, we'd be the most successful ice cream store in the world, for sure, because the right people just somehow overcome every challenge, and they just always seem to win, and so I would say, if I was giving entrepreneurial advice to somebody, I would say, especially when you're small, make really sure that you get the right people. And getting the right people does mean specific skills sometimes, but it also means that they have that special something that makes them team, somebody that you don't have to be somebody that that you want to go out after work with every day. It doesn't have to be like that, but it does have to be somebody that you enjoy spending time with and that you respect and you work with. So I would say probably the biggest lesson is it's all about people.
Yeah, yeah, and on all levels. I mean, I think that is the lesson for both sides of your points there, right? It's you got to build for the people.
That's right.
You got to
That's right.
hire the right people. Yeah,
That's right.
yeah, yeah. You can't hide in a corner, and you can't do it by yourself. Like you have to. It is very much, yeah.
Yeah, you just have to hire really, really, really well. And if you do,
Yeah,
you're probably going to be in good shape.
yeah, yeah. I cannot agree more. So and a shout out to the DATAVERSITY staff who work so hard and are amazing. I am grateful for them every day. Um, so tell me, Mike, what is your definition of data? I mean, you've worked with it most of your career.
Yeah. I guess for us, it's a large collection, a very, very large collection of measurements and facts, basically, that we use for analytics and planning. And some of that data is values. Some of that, that represents specific things. Some of that is actually not numerical. Some of it's text. In fact, over the years, we've gotten very good at using techniques to accept and work with most any kind of data. And I think that when we combine that data with some context, we can turn it into information. And that is like if you look at like the mass of what we actually have stored away, it's just tons and tons and tons of data, but it doesn't really become valuable until we add the context to it. When we add the context to it, which can include kind of that history, comparisons with other things, other systems, sometimes with other enterprises, when we combine it with knowledge that we have about what things ought to be doing and how they ought to look like when we measure them, that information starts to become incredibly valuable. So I guess that's kind of how I think about it at its root.
Yeah, yeah, very nice. So, Mike, do you see then the importance of data management and the number of jobs working with data increasing or decreasing over the next 10 years, and why?
Oh, I think just massively increasing. I think that's one of the things that has probably changed the most over my career. I mean, it's hard to believe. And I think some of what drives that is that, in today's world, we have enough capacity to store, incredible amounts of information. I still remember when I was in graduate school and in a advanced database design class, and the professor at the time said, he said, I predict that in your lifetimes that data storage will become so cheap that you don't really need to delete it. You just mark it deleted, but there's no point in ever cleaning up the space. And I remember like everyone kind of scoffed at that one. You got to be kidding me. We're talking about kilobytes, right? In those days. And if you look at it today, it's kind of where it's at. And maybe equally important to being able to store that data is that the capacity now exists to process that data too, in terms of throughput and networking, and in terms of raw processing power. And so I think that the amount of data created in the world, I think this is fairly well documented, is just going up astronomically. In fact, I think there's kind of a realization now that in a lot of disciplines, including my own, that the data itself is a valuable thing, really valuable thing. A lot of our customers, in addition to using our analytics and our UIs and things, they take the data and do their own things with it. The data all by itself is incredibly valuable, sometimes for much different uses than we had ever sort of imagined. And so I think that the number of jobs and opportunities to participate in that is going to increase really significantly. I should say continue to increase significantly. And I think AI and ML accelerate that even more, right? I mean, the concept that took it as a software engineer, right? It took me a long time to wrap my head around the idea that we could actually get this thing to produce really useful results without actually teaching it step by step how to do it. We just give it lots and lots and lots of examples, and through this training process, it kind of can figure out the rest. That was a very foreign concept at one time for me. But I think now you're in this situation where AI and ML are they're already changing the world, and I think they're going to change the world a lot more than what you've seen so far. I think we're just kind of seeing the tip of the iceberg. But to make that work, you need lots and lots and lots of good, clean data. You know, how much do you need? As much as you can possibly get your hands on. And so I think, yeah, in fact, I heard someone say that that when it comes to the AI work, this is your fuel. But and I heard someone else say, well, it's not really oil, it's diamonds that you've got there. That's how valuable this stuff is. And so I think that people that know how to collect and store that data, people that know how to clean that data and get it into a really usable state, and then people that know how to use build the AI and ML techniques to process it. And then I think, even there's a large collection of jobs and people who know how to use those AI ML technologies in order to do things a little different way, sometimes a much different way, to really change the business processes to take advantage. I think all of those things are going to be great sources of jobs going forward. And so, yeah, I would say the importance of data and the availability of jobs is massively increasing.
So then what advice would you give to people looking to get into a career in data management?
I would say first, sound math fundamentals are pretty important. Even when it isn't obvious, why do I need to learn multivariable calculus, right? Yeah, but there is learning a lot of math fundamentals kind of trains the brain to operate a certain way. And I think there's a side effect that is very useful for CS and data management. And so I would say number one is, I would say great math skills is pretty important. Probably true of science skills in general too, in engineering skills. Engineering is really about problem solving. It has less to do with specific tools and specific techniques, and more to the approach that you use to solve problems. When I was in college, most engineering exams were open book, open notes, bring whatever you want, right? Because it's not about memorizing facts and details. It's about learning how to attack, problems, how to solve problems. And so I'd say math and also engineering science skills are useful. I would say for data, basic computer science skills are also very important. They teach how to organize, how to use, how to access. They teach a lot about efficiency, about some of the constraints that go into that in terms of not just CPU, but memory and networking and bandwidth and latency, lots of other things that kind of really matter. So I would say that's also, those CS skills are very helpful. I would say as you get into your career, building relationships is very important. If you're a data person, undoubtedly you will have to work with people that are subject matter experts that know something about that data. And as a data person, sometimes, most of the time, you really don't need to be, you don't need to be a biochemistry expert in order to help somebody with biochemistry data. but you probably are going to have to talk to some people that are. And so the people skills, I would say building those relationships and then building those people skills. People skills are important in every job, every single job, without exception. It's just really helpful. And one of those things that you probably learn a lot by working with other people and try to see things, the other person's way, instead of, when people have contradicting ideas to your own thoughts, I would say, just try it on for size. Just say, well, let me just think that way for a few minutes and see what the world looks like, from that view. And I think that goes a long way. And then I would say last is, everybody in those jobs needs to be able to write. I guess you can use an LLM to help you with that writing. That's perfectly legal. Maybe that should be on my fundamental list, learning to use LLMs. And I would say learning how to speak, how to present, how to, and that includes just participating in a group meeting where, there's a lot of ideas, being able to relay your own ideas in a way that people can understand. And I would say also to be able to stand up and give a confident presentation to people. Early in my career, I did not like speaking. I did it, but I didn't love it. And I remember giving a presentation one time in my first job. It was to a big user group, and I walked out on stage, and there were something like 1,000 people in the audience, and my heart was pounding. Now over time, I've learned that as long as you know what you're talking about, at least a little bit, it's actually a very rewarding thing. And if you just be yourself most of the time, that's enough to get you through. So I guess, yeah, what did I say? I say math and science, computer science fundamentals, build career relationships, learn how to connect with SMEs, subject matter experts, and then, be a people skills person. Be the person that everybody wants to work with. It's a lot of things to do, but none of them are all that hard. You just have to work at it.
Absolutely. And I can so relate being nervous about presenting. I've experienced the very same thing early in my career, petrified to present. But it's an important skill, especially as you move through your career. Oh, well, Mike, it's been such a pleasure. So I would be remiss if I didn't ask, if somebody wanted to find out more about Lakeside Software, where would they go?
Go to lakesidesoftware.com. That's a great starting point. Tons of data there, and it's a great place to begin.
Perfect. Thank you so much. Well, Mike, it has been a pleasure chatting with you today.
Thank you for having me. It's been a lot of fun.
Thank you so much. And to all of our listeners out there, if you'd like to keep up to date on the latest podcasts and on the latest in data management education, you may go to dataversity.net/subscribe. Until next time, stay curious, everyone. Thank you for listening to DATAVERSITY Talks, a podcast brought to you by DATAVERSITY. Subscribe to our newsletter for podcast updates and information about our free educational webinars at dataversity.net/subscribe.